Math 3, Unit 9, Section 5. So today we're talking about cross-section problems. And we just watched a video on how to slice 3D shapes and take out a piece of two-dimensional shapes. And so basically, if you look here at a cylinder, when they took out a slice of the cylinder, what did it become? A circle. But if you went up and down, do you see how it then makes a rectangle? Okay, and a lot of this is just visually seeing the slices in your brain. Okay, so A. First of all, this is called a hemisphere because it's half of a sphere, just in case you wanted to know. Okay, so A, what kind of cut? Oh, you can't see what I'm doing. There we go. What kind of cut do you think this A makes? Circle is correct. So slicing through there, that slice is going to make a circle. What kind of slice will B make?
Okay.
Yeah, or a half circle. Yeah. There are going to be some that make an oval, and actually ovals, their actual math term is called an ellipse.
That sounds way cooler than oval.
Yeah. Okay. Next figure. Anybody know what this is called? Trapezoidal.
That's my new
Pyramid. There you go. I think I spelled that right. Trapezoidal prism.
That's my new
Okay, so with this trapezoidal prism, so this one, even though it looks like the line might be a little bit off, it's slicing through the bottom of it. It's taking a slice sideways through that shape. Very good. And B, what type of slice do you think that's going to take? Yes. It's actually just going to be a trapezoid. Questions so far? All right. So next we are looking at a football. So A, what kind of slice will A make? A will make a circle. And B will make a what?
An ellipse.
Very. It's like you guys were listening to me. Ellipse is correct, which some of you call an oval, but in math it's actually called an ellipse. Or an ellipse. Do they say that? Some people maybe say that. Why? Great question. I don't know.
Ellipses is the three dots.
That's right. Thank you. See, that's why I teach math and not English. Okay. Next one. It says, draw and describe the solid of revolutions formed by rotating this quarter circle about the axis of revolution. So if this were to rotate, and we're not going to draw it, okay? If this were to rotate really fast around the x-axis, what type of shape is it going to make? It is. It's going to make a hemisphere. Okay, now the y-axis is a little bit different, but you have to think about it. So this time it's going around the y-axis. So think about this line. So if this line is kind of going back and forth, it's a cylinder, but it's going to have a hole in it. So we're going to write this is going to be a cylinder on the outside. With a cone-like shape as a hole inside. Oops, sorry. Okay, we will draw, though, on these figures. So it says for each of the following solids, draw the two-dimensional shape that would be revolved about the indicated axis to generate the solid. Okay, so they didn't indicate, well, yes, they did. So they're indicating the x-axis here. Okay? So what type of shape, two-dimensional shape, would you be able to have there that would end up making a 3D? Close. It would actually be an ellipse, and we'd specifically do half of an ellipse. Okay? And so that would rotate and then make this, it's actually a watermelon. Okay, so I'm just gonna write over here, half of an ellipse. Okay, and for this tree here, it's not really a specific shape, but could you draw what you would want, what you would need in order to make a three-dimensional tree when you rotate the two-dimensional shape? Kind of, or like a triangle, but you could actually just draw it even like this. So we have like our tree, and then it goes like this, kind of, I think.
Are we just
It-
drawing like half a picture thing?
Pretty much. Yeah, and then if that was rotated about, and I'm sure you guys draw much better than me, it would end up making a tree. Pretty exciting stuff. All right, do we have any questions? So all we're doing is taking a slice from a 3D shape and figuring out the two-dimensional shape.